Hi and welcome everybody also from my side to today's Meet the Experts talk on preserving and analyzing large-scale Twitter data. As introduced, I'm Sebastian Schellhammer and I'm a doctoral student here at GESIS in the KTS department, Knowledge Technologies for the Social Sciences. Previously I did my master's in computer science and now I do research related to scientific online discourse. In my research, I mostly work with the Twitter data, Twitter or X data that I'm going to talk about today, and I contributed to the preservation and sharing activities of this dataset, and that's why I'm the one presenting today. During the next 30 minutes, these 4 questions will guide us through the talk. We start by looking into behavioral web data, why that type of data is important. We address the question why and how do we preserve this kind of data, what are challenges when sharing the data, and ultimately we'll look into how people make use and analyze the data. So first of all, looking into behavioral web data, instead of showing you some definitions, I just brought this image here, which makes it easy to grasp what this type of data is about. For example, every minute, users on Twitter or nowadays X send around 350,000 tweets per minute. On WhatsApp, users send 41.6 million messages and so on. So there's a lot of data created by user behaviors on the web. Here at KTS, we deal with the following type of behavioral web data. First, social web activity streams, so posts, shares, likes, and so on. And this is where the Twitter dataset that we talk about today belongs to. We also work with web search behavior coming from GESIS search, for example, browsing, navigation behavior, but also more low-level traces like scrolling behavior of users, gaze behavior coming from eye-tracking instruments, and many more. Why is it data important? Well, it's important because you need this kind of data to understand the evolution of the web, because basically the web is based on all those human interactions that contribute to that, and it's a very good way to measure more natural human behavior on a very large scale and great detail. It allows real-time data collection as opposed to more traditional survey-like data sets. So there's a very great potential to complement these more traditional social science data collections. And looking from the computer scientist perspective, many algorithms, many models rely on this data. If we think about the image before, if we think about Amazon, about recommender systems, and also if you, or you might have seen it in the previous talk about large language models, that these language models are trained on user-generated data, and in some way they replicate the behavior that's actually inside this data, so the behavior of the users that are part of this data set. So we've seen that this type of data is very important, and the Twitter data set I'm talking about today is also behavioral web data, and we'll next ask the question why we actually need to preserve it, because usually if you're in research, you might know this way of collecting data. I will call this retrospective data collection. Basically, you have some research goals. Let's say it's to identify different attitudes and tweets about climate change. And you have some experts and you curate a list of keywords with climate change, global warming, and so on. And then you go to these platforms like Facebook, Twitter, Instagram, Amazon, and they might provide some APIs, so some computational way to actually retrieve data from these platforms. And you then end up with a collection of retrieved tweets. So it's actually, yeah, sometimes works well, but the question is, why do we need some proactive preservation of data? Why is it not sufficient to just retrospectively collect data? The first reason is the dependency on the platforms. So with this retrospective data collection, you're very much dependent on the access to these APIs, right? And a very prominent example is that Twitter, nowadays X, closed their free API access early last year. And that means a lot of researchers could not do this retrospective data collection anymore. They could not access other researchers' data sets, and instead they, to still have access, they could pay starting from $100 a month to get 0.3% of the tweets that were previously the free API daily limit, or up to $42,000 a month to have the same level of access, which for most researchers pretty much money. So this is the first reason. You're dependent on the platform, that you have some long-term access on the platform. The second reason, so even if you have some agreement that you have long-term access, the problem is the data in the platform is not persistent. And that's because if we think about Twitter or other social media platforms, the posts are deleted either by the platforms. For example, they remove bots, they remove other fishy content, but also obviously the users themselves can delete their whole profiles, they can delete individual posts. And there was a study about that, and it said that 1 out of 16 tweets is not available anymore after the following 24 hours. And if we look in a longer perspective, that after 1 month, only 84% of the tweets can be found. Now you might say, okay, 15 out of 16 tweets, that's okay. I don't need that much data. That's not a problem for me, but I will show you that this data decay problem is not just about the quantity of the data that you can retrieve, but also about biases in what data you can actually still retrieve. Because research has shown that there are biases in what posts are more likely to get deleted. So that means if you collect data retrospectively, also your dataset might be biased. There are some very obvious examples. If you want to investigate, analyze bot behavior on Twitter, since Twitter hopefully removes a lot of bot content, your dataset that you collect retrospectively might be biased in the way that you see less bot content, or that certain bots are removed from the data. Also, the same way goes for analyzing hate speech. Hopefully a lot of hate speech content is already removed by Twitter, so if you collect the data after a certain time, then you might not be able to retrieve this data and to analyze it. But there are also some less obvious examples of data decay and of the biases that brings. In some study, we analyzed the ratio of deleted tweets, and we compared tweets that share URLs to anti-science domains versus tweets that share URLs to pro-science domains. By anti-science domains, we mean websites or domains that share or that have previously shared fake news about scientific studies and something like that, conspiracy theories. And by pro-science domains, we mean domains like journals, nature.com, and domains like that. And we've seen that the ratio of deleted tweets is higher for anti-science domains. So if you would look into such phenomena, you always need to think about potential biases in the data that come from this retrospective data collection. Also, preserving the data facilitates reproducibility. If we think about the following scenario, let's say other researchers already collected the data immediately after the data was created. So they are not dependent on the platform anymore. They do not have this data decay problem. And they train some new algorithms, some new model on the data, and they publish the results. And then half a year later, you want to reproduce what they actually did in their study. And the terms of services of Twitter have led to a very common practice that researchers would share their data sets only through the tweet IDs. So they do not provide any tweet content, they do not provide the author names, the tweet text, but just the Twitter ID. And then other researchers would go to the Twitter API and rehydrate all these tweet IDs to get the actual tweet content. And then, even though initially the researchers didn't have the problem of the dependency and the data decay because they already have the data set, if you want to reproduce the results, you will face the exact same problems. You're dependent, that you still have access to the API, and that not too much of the data is already gone. That's why it's very important to preserve data, especially by archival organizations like we are here at GESIS, to also facilitate this long-term reproducibility. Ultimately, one more reason for preserving data is to enable data exploration at the data collection stage. If we think again about this data collection example that I showed you before, we have this list of keywords, we collect data, and at some point we might ask the question whether this list of keywords is actually complete or whether we missed something in our data, because if we haven't seen the data yet, it might also be difficult to come up with a very good list of keywords. And if we have this preserved Twitter archive, we're actually able to identify additional keywords. For example, we have this at the left bottom side, we have these tweets that we extracted from the API, and we can now look into semantically similar data in our preserved Twitter archive and then identify additional keywords that we might have missed before. But this is only possible if you have already this large archive at hand. And it's way more difficult to do this by only relying on the APIs. So these are the reasons why preservation is very important. And we will now continue with how we actually did collect the data here at GESIS and also together with other institutions. The data collection was done using Twitter's 1% streaming API, which is or allows real-time data collection. That means once a tweet is shared, it was entered into the API, and this API delivered 1% of all the tweets that were posted. And this is a random 1% sample, so it's independent of the language, independent of users, etc. So the only reason why they would be included is based on the millisecond timestamp. So if you would create a tweet at a certain millisecond time, then this would determine if the tweet is part of this 1% streaming API. And we had multiple crawlers at different locations to prevent gaps in the data. So multiple servers hosting these crawlers around Germany. You can see that it's just an overview that at multiple days we had different crawlers, and due to changes in APIs and locations, also some crawlers changed over time. And with this methodology, we ended up with this Twitter archive that contains 14.71 billion tweets that were collected over a period of more than 10 years, from early 2013 until June last year. And to our knowledge, it's the largest continuous tweet archive for research purposes, with 3.5 gigabyte zipped per day per crawler, and in total it's then around 20 terabytes. So we can say it's very, very large scale. To get some intuition, these are the monthly numbers of tweets that we have in our archive over time. And yeah, just from looking at the numbers here, we see it's very large scale, but the question is also whether we have a good data quality, especially if we look at these gaps here, for example. The question might arise whether people tweeted less during these months, or whether we actually missed part of the data due to server outages. That means our crawlers were not running correctly, or because the API of Twitter was down, or there could also be other reasons. To check the data quality of this Twitter archive would actually, or could be actually, very easy if we just look at the numbers in our archive, let's say on a daily basis, for each day, and then we divide it by the total number of tweets that were posted on this day on Twitter. And if we have 1% of that, then we know we have collected all the data from this API. But this is not possible because there aren't any statistics about the total number of tweets on Twitter per day. Instead, what we did, we used another large external collection of tweets that was collected with other means than the 1% API, so with other filtering mechanisms, and it was not collected using the 1% API. And then starting from this data set, from these 170 million tweets, we measured how many of these tweets are in our archive. And in the graph below, we see that on the top there are again the monthly number of tweets in our archive, and at the bottom we see the percentage of tweets from these 170 million that were actually in the archive. And the red line is what we would expect, so this is the expected 1%. And we see that before 2017 there were like 3 minor data gaps where we're very, or a little bit below this 1%. But then also these gaps that we see after 2017, like here in the beginning of 2019, for example, these are not data gaps, but people just posted less. And we see that because the retrieved ratio of tweets is very close to the 1%, so to what we expect from our data set. That means in total we could say that we have a very large scale and very high quality Twitter archive data set. And that also means that here in GESIS, but also other institutions, other researchers are very much interested in working with that kind of data. And that's why we need to talk about how to share this kind of data. As we've seen earlier, behavioral web data tends to involve sensitive information, so we cannot just share it. Although the users voluntarily share content on these platforms, they do not provide explicit consent that this data can be used for, let's say, research purposes. So when we think about sharing, we need to consider various legal, ethical, licensing constraints, starting from ethical concerns like in our Twitter dataset, if we only look at individual tweets, most of the time we just take them out of context because they were actually embedded in some kind of conversation. They were replied to other tweets, or they belong to a collection of tweets. Also, we need to consider various national, international laws like GDPR, but also the licensing aspects coming from the Twitter terms of services and other legal aspects. One way to share this sensitive information would be to anonymize the data. So we just remove the sensitive part of the information, but it's or one needs to be very careful about that, as this example here shows, which is admittedly it's a little bit older, but still very relevant. So it's the example that AOL released search logs in 2006 for research purposes, and they anonymized users, but then some news media journalists and other researchers, I think, they could identify users from these queries, and which ultimately led to some lawsuits, and the CTO of AOL had to resign and was ranked as one of the dumbest moments in business by CNN Money. So this example shows one needs to be very careful when anonymizing and sharing this kind of data. And here at Gesis, what we do is we still offer this kind of sensitive data, but then only within our secure data center, or by contract-based sharing. And similar to AOL, we provide public non-sensitive data offers. So we create these non-sensitive derivatives, and one of them, the non-sensitive version of the Twitter archive, is TweetsKB, that provides public access to a cleaned and anonymized English language version of the Twitter archive that is enriched with different features. And the TweetsKB is what I'm going to show you next. So as I said, it's a subset of the Twitter archive. It contains only English and spam filtered tweets, and it's published using some knowledge graph related standards, I would say. I don't think it's too important here. And obviously we do not share all the tweet data because of the sensitive information, but we only share the tweet metadata, so when a tweet was created, how many retweets the tweet got, what were the mentioned hashtags and users, and we also annotate pre-computed features that capture some of the semantics, like the entities that were mentioned in the tweet, the sentiment scores, geotags, and some others. But what we do not share is the full text. We do not share the user IDs, and that's our way to make this a data offer that we can publicly make publicly accessible to other researchers. For example, so this is publicly available. You can just download the data on Zenodo or in our Datorium, and it has been downloaded around 30,000 times, so it's used quite a lot. And coming next to using the data, I will show you examples on how people use either TweetsKB, so this public non-sensitive data offer, or also the whole Twitter archive. For example, if you want to look into tweets from other languages, TweetsKB isn't help because it's just English tweets. The first example is TweetsCov19, which is very related to TweetsKB because it's a subset of TweetsKB. It's a public corpus of anonymized COVID-19 related tweets. So it covers COVID-19 related online discourse on Twitter from October 2019 until December 2020, with a little more than 20 million tweets, and it's again annotated with different pre-computed features, and actually used in many research projects by different institutes. This also is, as you can see here at the top, the link is publicly available, and is used a lot by different research. Another example that comes from my research is investigating the evolution of scientific online discourse, here measured by the percentage of tweets in our archive that contain links to science-related websites like journals, science blogs, publishers, and so on. And by leveraging this Twitter archive that we have, we could then see that not only the absolute number of tweets with the links to these science-related websites increases, but also the relative amount of tweets. So basically we can see this as a proxy that the whole scientific online discourse on Twitter is getting more popular and having a larger proportion on the overall discourse on Twitter since 2013. Also, the Twitter archive was used to look at the German vaccination Twitter discourse as part of the DD4P Discourse Data for Policy project. And here the researchers extracted tweets from the archive based on the language. So they were interested in German tweets. They filtered tweets based on the post date because it was about COVID. And also they were filtering tweets by the relevance to the vaccination discourse using keywords. And then what they found out here, as shown in the figure, for example, one of their findings was that the sentiment in the German vaccination discourse overall is more negative than the sentiment of the overall or general German Twitter discourse. These are some examples, and I could show you a lot more, but given our time constraints, I just show you the titles of the papers that other people published or try to publish. So they look into analyzing security and privacy advice during the Russian invasion of Ukraine. They look into AI-generated faces in the Twitter user profiles. They look into multimodal claims. They use the Twitter archive as a representative sample to assess the quality of other Twitter APIs like the academic API and more down here. Coming to the end of this presentation, let's look at a brief wrap-up on what we have heard, starting with preservation. So we saw that there are many problems with this retrospective data collection. We are dependent on the platforms, we're dependent on having access to the APIs. We saw examples of data decay, that we have a lack of reproducibility, and also that exploring the data for data collection purposes is difficult by relying only on the APIs. Here at GESIS and also at KTS, we collect and preserve multiple datasets, multiple behavioral web datasets, and also we survey the data needs of other social science researchers. So what kind of data do they need? What kind of data are they interested in? What features are they interested in? And as part of the GESIS web data service, you can click one of the links below here to see a whole list of datasets that we have here collected at GESIS. To give you some examples, we collected or still collect fact checks where we have around 75,000 fact checks and corresponding claims from 13 fact-checking sites like Snopes.com, PolitiFact, and other organizations. We continuously collect data from Telegram and also from 4chan using their API. To give you some examples on what kind of data we collect at the moment, for ClaimsKG, there's also a link up here. So if you're interested in that, you can take a look. For data sharing, we saw that there are very strict constraints, legal, ethical, licensing aspects that we need to consider when we want to share the data. We need to be very cautious when cleaning and anonymizing sensitive data, so when providing these non-sensitive public offers. To share the data, as I said here at GESIS, we try to provide these non-sensitive data offers. By removing all the sensitive information, we look into scalable sharing of these data sets and also integrate these data sets into our secure data center to be accessible to non-GESIS researchers. And then ultimately, we've seen that data preservation and sharing enables research in a lot of different fields, from social sciences to computer sciences, and there's very high demand for these data sets, and to even foster this analysis of the data even more. We are also working on something called Methods Hub, which aims at supporting social scientists in using or applying different computer science methods in their analysis on this kind of data. To really come to an end now, I just want to advertise a small survey. As I said earlier, for the web data collection, we survey the data needs of other researchers. And I will show this QR code also later after the presentation. And it just points to a very short Google form, which takes like not even 5 minutes, I would say. And it will ask for the platforms that you're interested in, for pre-computed features and some other questions. So would be very helpful to us if you could answer that survey. Also, there's an upcoming talk on scholarly information extraction, 11th of July, and some contact information. If you have any questions beyond the discussion now, feel free to contact me or visit those links. And thank you for participating, and I'm looking forward to your questions and feedback. Thank you.